What up, athletes? Let's do this. All right. So we are going to, our learning target today is solving equations involving absolute value. So we're going to deal with absolute value a little bit. Take a moment, do this warm up, hit pause. We'll start in a moment. Hot dog. All right. So the big deal with absolute value, guys, don't make it difficult. It just makes everything positive. It measures distance. That's what absolute value does. We talked about it a couple weeks ago. Let's remind ourselves it just measures distance. So this is equals 0. Negative 2.1 becomes positive 2.1. Negative 5 2/3 becomes positive 5 2/3. Positive 34.7 stays positive 34.7. That's all it is. On a game show, the object is to end the game with as close to $0 as possible. If Dylan has 345 and Marisol has 290, which contestant is winning? Well, we know Dylan is 345 from 0. And remember, absolute value measures distance. So if I take the absolute value of 290, that is 290, which is closer to 0 than 345. So even though it's negative, Marisol is the winner. So Marisol is the winner. That should be a capital M, right? Forgive me, I'm spelling with my mouse. Maybe if I did cursive, we'll see. Would that be easier? I don't know. I can read it. Can you? So anyway, Marisol's the winner. All right. That is it for this part of it. Let's go ahead and start talking about today. Good warm up. Solving equations involving absolute value. The big part for your notes is right here. I don't need you to write any of the above stuff, but it is right here. For any real numbers a and b, if the absolute value of a equals b and b is greater than 0, then a equals b, or a equals negative b. We'll get into that. All that's saying is, if the absolute, so example they gave is absolute value of d is 3, so d can be 3 or negative 3, because the absolute value of 3 equals 3, and the absolute value of negative 3 equals 3. What it's saying right here, the reason why your b has to equal 0 is you can't have the absolute value of a equals negative 5. You can't have that. You can't have it be negative anything, because absolute value makes everything positive. So this is an impossible situation. Now I could have like the absolute value of a minus 5 equals negative 2, okay? Because then I can add 5 to both sides. I know, that was a great line. I felt it. Here, let me fix that. Whoa. And then what do I end up with? I end up with the absolute value of a equals 3. And there we go. Now that's something I can solve. But I'd have to have something else outside of the absolute value sign to be able to have a negative on the other side, other side of the equal sign. So those are things to keep in mind. Let's write this down. Ready, set, go. And I'm going to move on. And what we're getting here, the reason why you have two answers for every absolute value problem, well, most absolute value problems, is because it can go left or it can go right. That distance is, we're measuring distance, not the negativity. So the question, Clark says the solution set for absolute value of x is 8. Is he correct? Partially. Don't forget, absolute value of 8 is 8. Let's check it out. That is 8. But what else did he forget? He forgot about negative 8, because what's the absolute value of negative 8? It's also 8. So x can also equal negative 8. That's another possibility. That's why we have to account for two things with absolute value. Okay? Awesome. solve an absolute value equation when n is greater than or equal to 0. And the n it's talking about in this case is like the 4. We're just setting it equal to something. Okay? And I actually want to take this real quick and so this is absolute value of y plus 2 equals 4. So we have absolute value of y plus 2 equals 4. Now, let's agree together that once I give y a value, everything inside of here is going to equal one thing. Like, let's say y is 3. 3 plus 2 is 5. I'm going to have the absolute value of 5. It's going to be a number inside of there. So because of that, I know whatever I'm taking the absolute value of is not only going to equal it. This can be both negative and positive and will come out to 4. So if this, whatever makes this equal 4 or negative 4 is going to make it true. So in other words, I'm going to set up two equations. Whenever you have absolute value, you're going to set up two equations. I'm going to have y plus 2 equals positive 4 and y plus 2 equals negative 4. Because remember, the absolute value of 4 is 4, and the absolute value of negative 4 is 4. So I'm trying to find out what two different things will get me a positive 4 when I take the absolute value of it. And so I'm going to solve these at the same time. Because we do the same thing, right? I subtract 2 to get to the other side, boom. I subtract 2 to get to the other side, boom. And I end up with two different values of y. That crosses out, y equals 2. But over here, I still get y, that crosses out, equals, what's negative 4 minus 2? That's negative 6. So in this case, on this number line, we have y can be negative 6, or y can be positive 2. And what makes that possible? Well, let's find out. I'm going to plug it back into here. So I'm going to have, instead of y, let's put it in. I'm going to have 2 plus 2. Absolute value of that equals 4. What's 2 plus 2? It's 4. What's the absolute value of 4? It's 4. So 4 equals 4. That's a true statement. These are kind of our checks, right? Then let's try it with the other value. I'm going to have the absolute value of negative 6 plus 2 equals 4. And let's just write down the equals 4, see what happens. What's negative 6 plus 2? Well, that's negative 4, right? So what is negative 4? Absolute value of negative 4 is positive 4. Look at that, it works. Every absolute value problem, or not every, but I mean if it's 0, that's just 0, 0. It's not a positive and negative 0, but pretty much every absolute value problem is going to have two solutions. So, as long as it's possible, that is. Let's move on to the next slide. Load times are fun, right? Okay, what is the graph of the solution set of f absolute value f plus 5 equals 17? Okay, very similar to the last problem. Let me move stuff out of the way so we can use our white space over here nicely. And I end up with, all right, let's write it down. So if absolute value of f plus 5 equals 17, it means I can get inside this absolute value a value of 17 or negative 17, because the absolute value of either one of those is going to be positive 17. So let's set this up. F plus 5 equals 17, and F plus 5, I'm running off my mouse pad over here, equals negative 17. And again, we're going to do the same thing to both, right? We're just going to get f by itself by subtracting 5 over. When I do to one side, we always do to the other. We're going to subtract 5 from both sides. Notice how I just do it simultaneously, because why not? We're doing the same exact thing. I'm going to get f, that's gone, equals 17 minus 5 is 12. And I'm going to have f equals negative 17 minus 5, right? This one was a war, 17 won by 12. This one's a party, it's a negative party, and they add up to 22, negative 22. So which one has a 12 and a negative 22? Well, let's see. Not that one. That is a 12, it looks like, and that is a negative 22, but this one's weird. Oh, look at this one, the one I'm covering up, right? Oh, poop. Ah! Get off my drawing. Look at that, negative 22 and 12, so it's going to be D. Okay? Got to solve that twice. Don't forget, you can always back it up and pause it if you need to see that written work over here. Today's not going to be a super long lesson by any means. Absolute value of 3x minus 4 equals negative 1. Let's talk about this. So the absolute value of 3x minus 4 equals negative 1. I said this earlier, but guys, no matter what I do, when I take an absolute value, it's always positive. It cannot be negative 1. That doesn't work. There is no answer. That's a no solution. Our n value is always what the absolute value is equal to, has to be greater than 1, as long as it's just an absolute value on the other side. Like I said, if I were to go ahead and, let's say, over here I threw in a minus 5 equals negative 1. Well, that's different, because then I don't just have the absolute value over here. I have to add that 5 over, right? Add that 5, and now I have that this side is equal to positive 4. Well, that's different. But if we don't have that, if all I have is the absolute value on the left of the equal sign and a negative on the right, it's not possible. Boom, no solution. Okay? Or what they say is right here. Does everybody see that? That's called the null set, or no solution. Right there, null set. So if you ever have no solution, they're going to give you a null set. Awesome. And look for that. Sometimes, especially on tests and stuff, I'll put like this crazy looking equation, and then if you just pay attention, it's all equal to a negative. Or if you like get it down, like solve it down, like maybe you have to add or subtract some things over, you get that the absolute value equals a negative. It's like, oh, no solution. Boom. So what's this one? Again, it's equal to a negative. No solution. A right here. Boom. Told you we were going to boot scoop boogie through this pretty quick. All right. Depending on the size of each song, Luna's phone holds an average of 2,000 songs, give or take 250 songs. Write and solve an equation involving absolute value to find the maximum and minimum number of songs that Luna's phone can hold. Well, the maximum and minimum number of songs will differ from the average by 250 songs. Complete the table to write an equation that represents the maximum and minimum number of songs. The difference between the number of songs and 2,000, right? So we know that it holds an average of 2,000, but it's plus or minus 250. So let's see, let x equal the number of songs on Luna's phone. So we're going to have x minus 2,000, right, should equal 250. Well, now let's solve that twice. Remember? So I'm going to set this up to solve twice right up here. I know they have it worked out down there, but I like to do it live for you. So if I have the absolute value of x minus 2,000, excuse me, should equal 250, then let's go ahead and take away the absolute value right there. I meant to do that because not only should it equal 250, but we can have that x minus 2,000, because remember it's give or take, can equal negative 250. All right, so I'm going to add 2,000 to both sides. Getting better at writing with the mouse. I'm going to add 2,000 to both sides over here. Remember I told you I just kind of solve them at the same time because I'm doing the same exact thing to each one. Now, over here, we have a party. It's a positive party. They get together. I get 2,250 is the max amount of songs. But there's also got to be, just like there's a maximum, an upper bound, there's got to be a lower bound. So in this case, we're going to have a war, and it's 2,000 minus 250, which is going to equal x equals 1,750. So that means, depending on the size of the song you download, your phone can hold either 1,750 to 2,250 songs. All right? There's a bound there. That's one of the ways we use absolute values to find upper and lower bounds of things. Now, typically, it's a much more complicated type problem in real life, but we try to simplify it a little bit. And then last but not least, guess your age. Tamika wants to play the guess your age game at the state fair. If the guess is not within 2 years of her actual age, Tamika wins a prize. Tamika is 16 years old. So what is the least and greatest guess? This is a good thing to know because a lot of those fair games try to trick you. Let's see. So we've got Tamika's age. We're just going to let Tamika's age. We're going to let capital T be Tamika's age. I'm going to short it to TAM. That's supposed to be an A. G-E-A. I'm writing with a mouse, people. And so I can say the absolute value of Tamika's age. Wait, I don't want to do that. I'm sorry. I told you, when I make mistakes, I'm going to leave it in the video because I want you guys to see me, my brain working through it. We already know Tamika's age. Let's up with that junk. What I really want is their guess. Let's talk about their guess. So we're going to let GB guess. Let G be the guess. And since it has to be within 2 years, we're going to say, all right, absolute value of G minus 16. So the guess minus 16 needs to equal 2. It needs to be within 2 years of it. And when I solve that, I'm going to get G minus 16 can equal positive 2 or G minus 16. That's a terrible G. I felt it, but it is what it is. All right, can I salvage it? Yeah, that's better. Equals negative 2 because they can guess 2 years under. So that's really a 4-year gap, right? So their odds have greatly increased. So then add 16 to both sides. We're going to do that twice, right? Add 16 to both sides. And I get G equals 18. So what is my upper bound? My greatest guess is 18. So whoever this person guessing is can guess 18. And their lower bound, we get that G equals, it's negative 2 plus 16. Remember, that's a war. 16 wins by 14. So as long as they guess anywhere from 14 to 18, they win. That's pretty easy. So when you start seeing some of that stuff at the fair, you're like, oh, you have to give me within 2 years. Yeah, well, it's not that hard, especially if you're younger. It's when you get older, maybe that's a little harder, but even then they'll say within 5 years. And that means they can do 5 above or 5 below. That's really a 10-year gap. That's pretty doable, right? It takes a little bit of the impressiveness out of it. So this is the power of absolute value. And we're going to use it, and we want to make sure we understand it because it will be on the upcoming test. With that said, peace out. Where'd my mouse go? Right.